Suppose u, v, and w are all vectors in R3. Determine which of the following scalars vectors, or just don't make sense. Explain. All right. So I'm going to assume u, v, and w are all vectors, and I'm going to assume that they are associated with the x, y, and z. So I'll do a little coordinate plane here. This will be x, this will be y, this will be z. I will say that u goes this way, v goes this way, and w goes that way. Basically u, v, w associated with x, y, z. Kind of just alphabetical order. All right. So the thing with cross products is, so we have u dot v cross w. And so we're going to do the v cross w first inside the parentheses. The thing with cross products is it's a measure of how perpendicular two vectors are. So the way I do it, right hand rule, you place your right hand in the direction of the first vector, in this case v. You bend your fingers in the direction of the second vector, in this case w, and your thumb is going to point in the direction of the resultant vector. So v cross w is going to give us u. So, or y cross z will give us x. And so this is going to be the same as u dot u. And just like a cross product is a measure of how perpendicular two vectors are, a dot product is a measure of how parallel two vectors are. So these two vectors are perfectly parallel with each other, and so it's going to be 100% or 1. A dot product is a scalar. The magnitude of the scalar is going to be the first vector times the second vector, which is going to be u, times the angle between these two vectors, or times the cosine of the angle between these two vectors. Since they're the same vector, the cosine is going to be 0, which is, cosine of 0 is 1. And that's what I mean by 1 or 100%. So this is going to be u squared. Another way of looking at this, of basically calculating dot products, is looking at them in this terms. So you have your x, y, and z coordinate here, and you just multiply each term by the other one. So u times u squared, plus 0 times 0, which is 0, plus 0 times 0, which is 0. And this gives you u squared. So this is how we can, two different ways we can kind of look at the dot product here and show that a vector dot itself is just going to be the magnitude, i.e. scalar, not vector, of itself squared. And that's how we do the first part, part A. Part B is now going to be u cross quantity v cross w, little vector symbols. And v cross w, that's going to be u, where I talked about how that is. And so this is going to be equal u cross u. And I said earlier how cross product is a measure of how perpendicular two vectors are to each other. Well, yes. The magnitude is each vector times the other one times the sine of the angle between them. So in this case, since they are the same vector, the angle between them is going to be 0 because they're parallel. And so sine of 0 is 0. This is going to equal 0. Another way to look at cross products in 3 dimensions is you do I, j, k, write the top vector. We'll call it u0, 0, just like we did up here. Second vector will also be u0, 0. And you take the determinant of this matrix. This is supposed to be an I, not a 1. And then, so we look at the i's, do I, 0 times 0, minus 0 times 0, minus j, u times 0, minus u times 0, terrible, plus k, and that's also going to be u times 0 minus u times 0. Long story short, this is all going to be 0. So a vector cross itself will be 0. All right, now I have our third scenario right here. This is going to be u cross v dot w. So v dot w is going to be a measure of how parallel v is to w. So we said here, this is going to be a scalar, magnitude of v, magnitude of w, times the angle between them, which we know is 90. So it's going to be the cosine of 90 degrees. Cosine 90 degrees is 0, so this is going to equal 0. So this is going to be u cross 0. But we got kind of a bigger problem. You might be like, oh, that's just 0. Well, no. The issue is dot products always give you a scalar. And a cross product is always a cross product between two vectors. And so we get a scalar here. This scalar can't be crossed by you can't cross a scalar and a vector. It just doesn't make sense. Therefore, this just doesn't make sense. It does not exist, or just don't make sense, as the prompt said. So this one doesn't make sense because v.w gives you a scalar. You can't cross a scalar with a vector. So hope that helped. See you next time.